Just because something doesn't look like an indeterminate form, 0 divided by 0 or infinity divided by infinity, doesn't mean you can't use L'Hopital's rule. You might just have to rearrange the equation to recognize it. Let's look at the limit as x goes to infinity of x times the sine of 1 over x. If we just tried direct substitution like we should always try, we would have an infinity right there for that x, and then the sine value at 1 divided by infinity. As x goes to infinity, then 1 divided by x is going to go to 0, and the sine value at 0 is a 0. So we have infinity times 0. That's not an indeterminate form that we can recognize, but we can rearrange this. And look at the limit as x goes to infinity of sine of 1 over x divided by a 1 over x. I'm really just rewriting x as 1 divided by 1 over x. And by doing so, now we can recognize this as the indeterminate form 0 over 0. Right? Both numerator and denominator here approach the value of 0 as x gets larger and larger. So we have an indeterminate form that we can use L'Hopital's rule on. And L'Hopital's rule says that we can differentiate numerator and denominator. So we will differentiate sine of 1 over x as cosine 1 over x times the derivative of 1 over x, which would be minus x to the minus 2, or 1 over x squared. We will also differentiate the denominator, 1 over x, and that differentiates to minus x to the minus 2, or 1 over x squared. Now, with a little bit of algebra, negative x to the minus 2 is going to cancel with negative x to the minus 2. We're left with just the cosine value of 1 over x. And here we have no problem directly substituting, as that x gets larger and larger. As we send it to positive infinity, then 1 divided by x is going to get smaller and smaller. It'll go to 0, and the cosine value at 0 is a 1. So we were able to recover a limit using L'Hopital's rule, but we first just had to rearrange the equation to get it into a recognizable indeterminate form.